I welcome you for the second lecture. So, in the last lecture we look at how can we find out the resultant of various forces. Now, let us look at the reverse process of that, that means the resolution of a forces. So, now so, basically this is the reverse process of what we have done for the resultant of the forces, wherein we have various forces and then we find out a single force which has the same effect of all these forces. This is the reverse process of that. So, here this is the process of finding two component of a force which will have the same effect or same external effect on the body. So, let us say I have a force F which is acting on a rigid body and it is making an angle theta, let us say from the x and y axis. Then this is the process wherein we can break this force into two component x and y. So, this force F can be written as Fx plus Fy. If I and j are the unit vector along x and y, then they can be written as Fxi plus Fyj, and the value of Fx is nothing but f cos theta, the projection of f along x direction, and Fy is f sin theta. And there is a relation between theta and Fy and Fx. So, tan theta will be Fy divided by Fx. Now, we will see that the body will be experiencing different kind of forces. So, let us very quickly discuss the definition of the contact force and body force. So, let us first discuss what is a contact force. A contact force is produced by direct physical contact. Okay. So, for example, let us say I have a supporting surface and you put a body on it. Okay. So, herein the body will experience contact force because that is in contact with the supporting surface. We can also have a situation wherein we have body force, and this body force is generated by virtue of positioning of the body within a force field. So, for example, you put a body in electromagnetic field, then the body will experience a force, okay, and in this case it will be a body force. So, you can have electric field, magnetic field, or the gravitational field. So, the forces which are generated by the field and you place a body, then it will experience the body force. Now, let us look at the concept that we have learned by a simple example. So, herein there are four forces which are acting on a bolt, okay, and the question statement is determine the resultant of the forces on the bolt. So, you can see here there are four forces, their magnitudes and direction is given, and the question is can we reduce this force system into a single force. Okay. So, first thing we have to see here that the forces are concurrent because their line of action they meet at a single point. Okay. So, these are the example of concurrent force, Now, to determine the resultant, let us resolve each forces into rectangular component. Okay. So, because here the x and y axes are given, so let us resolve them along the x and y direction. So, we have 4 forces F1, F2, F3 and F4, and their magnitudes are 150 Newton, 80 Newton, 110 Newton and 100 Newton. Their x component will be, so for example, F1, it will be F1 cos 30 degree. So, this will be 150 cos 30 degree minus 80 sin 20 degree, 110 cos 90 degree, 100 cos 15 degree, and similarly the y components will be 150 sin 30 degree, 80 cos 20 degree minus 110 and minus 100 sin 15 degree. So, we can sum them up and find out what is R x, we can sum them up, can find what is R y, and then capital R will be square root R x square plus R y square and 10 alpha, wherein alpha is the angle that the resultant is making from the x axis, will be R y over R x. Now, let us look at what is the moment of a force. This is also called torque. So, suppose I have a rigid body, and on this rigid body you apply a force. Okay. Then this force has a tendency to translate this object, and also this has a tendency to rotate this object. Okay. And this rotational tendency, it is called the torque or the moment of the body. Okay. So, when we apply force on a body, it has the tendency to move the body in the direction of its application, and it can also tend to rotate the body about an axis. So, this rotational tendency is known as the moment m of the force. Okay. So, for example, here this is the axis and the force is applied. So, let us say it is passing through this O, then the moment m will be F times d, where d is the perpendicular distance from this force to the point O. Okay. Now, the moment can also be find out using r cross F, where this r is the position vector which run from point O to any arbitrary point. on the line of action of f. So, for example, you can take this as r or you can take that as r. So, any position vector which runs from point O to any arbitrary point on the line of action of force. Now, in this course we will follow the following sign convention. So, if the force has the tendency to rotate the object in anti-clockwise, then we will take its moment positive, and if it is clockwise, then we will take the moment negative. This is the convention that we will follow. Now, let us say that I have a rigid body, and on this rigid body a force R is acting on it. Now, this force R I can divide into two component, let us say they are P and Q. Then the moment about O will be R cross R, but since R I can write down in terms of P and Q. So, this R can be written as P plus Q, and this will be R cross P plus R cross Q. What does this mean? This means that the moment of a force about any point is equal to the sum of the moments of the components of that force about the same point. So, this is the statement that we have just shown, that you take a force, you break it into two force, then the moment of that force about the point will be equal to the moment of those forces that we have broke about the same points. So, let us look at the same concept once again. So, suppose I have an object or a rigid body, and let us say these are the x axis and the y axis, and let us say the force F is acting on it. So, this force F I can break into Fx and Fy, then the moment about O was R cross F, but now this F I have broke into two, Fx and Fy. Now, about O, this Fx has a tendency to rotate the object in this direction, and Fy has the tendency to rotate the object in that direction. Now, this Fx has a tendency to rotate it in the clockwise direction. So, therefore, it will be negative. So, therefore, the moment will be minus Fx into the perpendicular distance, which is y, and this one is x. So, it will be minus Fy plus Fyx. Now, let us see the same point using this equation. So, moment m will be r is xi plus yj cross f is fxi plus fyj. So, this is just a vector product. So, this will be I j k x y 0 and fx fy 0. So, this will be k times x fy minus y fx, which is the same. Okay. Sometimes this is also called the Varignon theorem. So, now let us look the concept of moment by an example. So, let us say a force of 800 Newton is acting on a bracket. So, this is a bracket, and let us say we were asked to determine the moment of the force about point B. So, this question we can solve by different way. So, let us say we use the equation of moment about B equal to r cross f. Okay. So, in the Cartesian coordinate system, let us fix our axis here. So, r is any point on the force. So, let us say this is my r. So, r is minus 0.2 I plus 0.16 j, wherein I have converted this distance in meter. Okay. And the force F is 800 cos 60 degree I plus 800 sin 60 degrees j. Okay. So, this is 400 I plus 693 j, because cos 60 degree is half and sin 60 degrees is square root 3 by 2. Okay. So, therefore, the moment will be r cross f I j k minus 0.2, 0.160, 400, 693 and 0, and this will be I to 0 minus j 0 plus k minus 0.2 into 693 minus 400 into 0.16, and this will be minus k 138.6 plus 64 equal to minus 202.6 Newton meter, and its direction is k cap. So, this is one way of calculating the moment about point B. We can also find out the moment by using the formula F t, where d is the perpendicular distance from point B to the force. So, let us use that method and let us see if the answer is same using m equal to F d, where this d is the perpendicular distance from B to the force. Now, force is a sliding vector. So, therefore, we can slide it and we can draw a perpendicular. So, this is d, and this I can write down as d1, and this I can write down as d2. So, d becomes d1 plus d2. Now, d1 is very easy to determine because this is 60 degree. So, therefore, this will be 60 degree, this will be 30 degree, and since it is perpendicular, this will be 60 degree. So, therefore, this is 60 degree and this one is 30 degree. Now, cos 30 is 200 mm divided by d1. So, therefore, d1 will be 200 divided by cos 30. So, this will be 200 divided by square root 3 by 2, which is 400 divided by square root 3. So, d1 is 0.4 divided by square root of 3, wherein I have changed this distance into meter. Now, to determine d2, let us say that this point is C, this point is D, then d2 will be AD cos 60 degree, and AD will be 0.16 minus CD, because this is 0.16. So, AD will be this distance minus that distance, and CD we can very easy find out. So, my AD will be 0.6 minus 0.2 divided by square root 3. So, therefore, d2 will be AD cos theta, it will be 0.16 minus 0.2 divided by square root 3 multiplied by cos 60 degree, which is 1 half. So, this is my d2, d1 I already know. So, therefore, the moment will be the force multiplied by the distance, distance is d1 plus d2. So, d1 is 0.4 divided by square root 3 plus d2 is 0.08 minus 0.1 over square root 3. So, therefore, the moment will be, let us simplify this, square root 3 plus 0.08 multiplied by 800, and this comes out to be 202.6 Newton meter, which is same as we have obtained earlier. We can also calculate the moment of this force using the principle of transmissibility. So, let us slide it along its line of action. So, we have slided it on the horizontal axis. So, this is the force 800 Newton and this angle is 60 degree. Now, the moment about B will be, this force we can break into the x and y component. So, the x component will not contribute because its moment about B will be 0. So, the only moment that is going to contribute is the y component of the force. So, the moment will be 800 sin 60 degree multiplied by d1 plus d2. Now, d1 is 0.2 meter and d2 we have to find. So, d2 we can find using 1060 equal to 0.16 divided by d2. So, therefore, d2 will be 0.16 divided by 1060 degree. So, this is the force multiplied by d1 plus d2, d1 is 0.2 plus d2 is 0.16 divided by square root 3. So, therefore, this will be 80 square root 3 plus 64 and this comes out to be 202.6 Newton meter. Now, we can also translate this force on the y axis. So, this is the force that we have 800 Newton, we can again break it into x and y components. So, in this case the moment will be 800 cos 60 degree multiplied by d1 plus d2, wherein d1 and d2 are this distance. So, again let us see what is d2. 1060 degree will be d2 divided by 0.2. So, d2 will be 0.2 square root 3. So, it will be 800 cos 60 degree multiplied by d1 is 0.16 plus d2 is 0.2 square root 3 and this again comes out to be 202.6 Newton meter. So, we have seen using various principles like the principle of transmissibility, moment equal to r cross f or fd, we get the same result. So, there are various ways that you can find out the moment, and with this let me stop here and let us see you in the next class. Thank you.